Hello everyone, welcome to my channel. In this video I have this integral that I would like us to work on. It's the integral from 0 up to 1 of dx all over 4 minus x squared. Just one integral. It will take us some time to complete this, so let's start then. So it's the integral from 0 up to 1 of dx all over 4 minus x squared. Now this is page 1. Looking at this one here, with a minus there, sign substitution comes in, but we have to change 4. We need a 1 here. The reason why we need a 1 there is because of the following. Remember, we say sine squared theta plus cos squared theta equals 1. And so if we make cosine squared subject of formula, we're going to get 1 minus sine squared of theta. This part here resembles this part, except for the 4 there. So we have to get rid of that 4. So we can have 1 and then we'll replace it with cos squared as follows. So this is going to be the integral of from 0 up to 1 of dx. We're going to make the common factor in the denominator as 4. Take it out. 4 into 4, 1. 4 into x squared, it has to be x squared over 4, like that. And the 4 is dividing, so we can take it out. This is 1 over 4. Integral from 0 up to 1 of dx all over this part. Now watch how I'm going to write it. 1 minus, and I'm going to write x over 2, and I'm going to say the whole expression squared. And you agree with me, if you expand or remove these brackets, you're getting back x squared over 4. Now at this stage I am going to let sine squared, remember here, we're going to let sine theta be equal to x over 2. So let sine of theta be equal to x over 2. From here, the first thing, because we have limits of integration, we'll have to change them. So solving for theta, we get theta equals sine squared, sine inverse or arc sine of x over 2. Sine inverse or arc sine of x over 2. Now we're going to say, now as x approaches 0, lower limit, theta must approach sine inverse of 0 over 2. You'll agree with me that this is sine inverse of 0, and the answer is 0. The lower limit remains unchanged. Moving on to the next page, we must change the upper limit as well. Page 2. So we're going to say as x approaches 1, we work out what theta approaches. As x approaches 1, theta must approach sine inverse of 1 over 2. You see here, we substitute 1 there, 1 over 2. And what is sine inverse of 1 over 2? You'll agree with me that this is pi by 6. Because sine inverse of 1 over 2, that angle is 30 degrees, and that's pi by 6. So now we have changed the limits of integration. What we need to do now is to work out the expression for dx. That requires us to differentiate both sides of this equation here. I'll first multiply by 2 and then differentiate. So basically we're saying 2 sine of theta is equal to x. Here you can see multiply by 2 both sides, and then we differentiate with respect to x. Derivative with respect to x of 2 sine theta must be equal to what you do on one side of the equation, you do the same on the other side. Derivative with respect to x of x. On the left, 2 is a constant, and we're going to say 2 times derivative with respect to x of sine theta is equal to derivative with respect to x of x is 1. And what is this? Well, chain rule here. This is 2. Derivative of sine is cosine of theta. Remember, we have theta here, and then we're going to say times d theta dx. Multiply, this is equal to 1. Multiply by dx both sides. We're going to get 2 cos of theta d theta, the answer is equal to dx. Now we have the expression for dx. This means that this integral now can be transformed totally to 1 over 4. Lower limit is 0, upper limit is pi by 6. Instead of dx, I'm going to have 2 cos theta d theta, and here I'm going to have 1 minus sine squared theta. Right. So we're going to say that integral is equal to 1/4 integral from 0 up to pi by 6 of what? Of this expression, 2 cos of theta d theta all over 1 minus sine squared theta. There you go. That part there must be replaced by that, and this is what we get. So now let's simplify. Remember I told you the denominator here can be replaced by cos squared theta now. Taking us to the next page, just to quickly finish this off, page 3. Basically we are now saying, let me put this one over here, and if you allow me to move this one down. Right, so basically we're now saying that integral is equal to 1/4 of the integral from 0 up to pi by 6, and that expression in the numerator stays the same, 2 cosine of theta d theta. In the denominator is cos squared theta. Remember this expression, like I told you, and obviously cos cancels one cos, 2 comes out, so we have 2 over 4 integral from 0 to pi by 6 over 1, obviously you have 1 here, all over cos of theta d theta. Now what is this? Well, this is the same as 1 over 2 the integral from 0 up to pi by 6 of sec theta d theta, and you know the integral of sec is actually the natural log of sec plus tangent. So this is equal to 1 over 2 natural log of sec theta plus tan theta, and we're evaluating this from 0 up to pi by 6. So what do we say? Keep half out like this, natural log of sec pi by 6 plus tan pi by 6 we can keep that for now, minus, doesn't really matter, and then we're going to say natural log of sec of 0 plus tan of 0, like that. Right, finishing this off. So page 4, almost done. Page 4, basically I'm saying that what we have now is that is equal to 1 over 2 open brackets natural log of sec pi by 6 is actually 2 over root 3, so that's 2 over root 3. I'm going to use round brackets now. Tan pi by 6 is actually 1 over root 3, 1 over root 3, and then minus sec 0 is actually sec 0 is actually 1, because remember sec theta equals 1 over cos theta, so therefore sec 0 equals 1 over cos 0. What is cos 0? 1. So 1 over 1, the answer is 1. So there you have natural log of, and tan of 0 is 0. So basically round brackets 1 like this, and that will be 0. Tan of 0 and natural log of 1 is actually 0. So this is 1 over 2 natural log of, here we have, remember, 3 over root 3. Denominator is the same, just add the numerators. This is what we have, minus 0, like so. And then this is just simplifies to 1 over 2 natural log of this one here. Remember root 3 over 3. So we have 3 over root 3, not root 3 over 3. So I want to simplify this part here. 3 over root 3 is the same as 3 over root 3 times root 3 over root 3. Rationalization of the denominator, remember? So this is numerator will be 3 root 3 all over. This part here is actually just 3, and this cancel. So the answer is root 3. So 3 over root 3, the answer is root 3. So this is root 3. And what is this? If we simplify this further, 1 over 2 times natural log of 3 power half, remember square root, And using laws of logs, the specific law of logs we're going to use is natural log of m power p equals p natural log of m. Now this form here is this form here, as you can see. It means I need this form to get to the answer. I'm going to take the power multiply. So take the power multiply, we're going to have 1 over 2 times 1 over 2 natural log of 3, which simplifies to a quarter of natural log of 3 as our final solution to this integral. All right, tell me what you think about this integral. Your feedback is greatly valued. All right, I'll see you in the next one.